Hi Mr. Leo, my name is Nikko Leo, and today I want to present about my mini project 1. So before start all the part, I will do a setting for the quarters 2. So now I will create a new project wizard, and then I'll save the folder, save the file inside the folder at the mini project 1. So our name is as testing setting. Then I will click next, and then the device memory is Cyclone 2, and then the device model is EP2C20F484C7, and then I will click next. And then now we'll need to create a VSTL file. But the file code are already generated inside the VSTL silent, so I will just copy and paste, and I make sure the name is correct. Name it as testing setting. Then I will click run to compile, and make sure save the VHDL file. Also, this one need to tick and wait for it. Okay, and we'll set the pin planner. And this one is for the LED and the switch. The location will be referred to the manual, which is this. So I'll copy the switch location and paste into the quarters. This one is the switch location. And the LEDR location, as also can find inside the menu. This is the LEDR location. And then if done, and I will click compile again. And OK. Then want to upload the code to the device, which will click this button and choose the device. As a USB blaster, and I will click auto detect. If can, then I will add the file, the output. Click the start, and I will show it by my video recording. After the code had been uploaded to the device, and already click the start button, and now when I switch the switch to high, and all the LED can be seen and follow, which means the switch I already set correctly. So that's it for part 1A. Now come to my part 1B, and here's my demonstration. As we can see that the LED already are divided into low frequency, which is from 50 MHz and lowest down to 1 or 2 Hz. So this is a light chaser with 1 Hz. So if I do the high and put back to down, switch to 0, and the light goes 2 by 2. Also, if I turn 4 of it, and the light chaser will goes 4 by 4. So that's it for my part 1B. Now comes to my part 2A, which is the hardware modeling. The 5 of the D flip-flop and the XOR gate have been connected and compiled into the DE1 board. So, and now also the 50 MHz internal clock from DE1 already slowed down to 1 Hz. So later we see the light is slow. So here got 2 inputs, which is the start button and for the reset. Also the 5 of the LED as an output, which is LED 0 to LED 4, sorry. And then I click the switch button to high and low. It will maintain it will generate the different pattern of the LED. And also the reset button, and I reset it. So this is for my part 2A. Now come to my part 3, and the question asks us to do a ALE module, which is the arithmetic logic unit that we can do some operation inside and display the result in this 7-segment display. Each of the function can be selected by using the mod S0, S1 and C0, which is this 4 input, and the start button here to on or off the system. So the carry will be shown in this LED 1, and the O0 will show in this LED R0. So let's start at the first function. Now I will demonstrating for the mod 0, and they got 4 function. The 4 function is the logic operation. So the mod is 0, and this one is not K. 4 of the function C0 is not K. So the first one 0, 0, 0 is 0, which is 2. The result is 2. So okay, then second mod is mod 1, so I turn the mod to 1. And then because mod 1 is the arithmetic operation, so 0, 0, 0 is 5, 1. Okay, now because this is the subtraction and the B is greater than 1, so it will the negative sign show out also. Also the carry LED. So that's all for my part 3. All of the function is implemented correctly, and the result also as the expected. So thank you to Mr. Leo.